Hello, my name is Nagasaya Kuraj, and my topic for the AWP ATT is the half-wave dipole antenna. The half-wave dipole antenna. Before going on to the half-wave dipole antenna, we have to know what is an antenna. Antenna is a piece of metal or a piece of wire which conducts or radiates the EM wave through the free space. The antennas come in many different forms. And one of the standard antennas which we use is the half-wave dipole antenna. The half-wave dipole antenna has the length half of its wavelength, half of the operating frequency wavelength, and it is also called as Hertz antenna. It is generally operated between 3 kHz to 300 GHz, and its structure is so simple, and it produces so many, and we can also create so many different complex shapes from its structure, and it also acts as a receptor and a transmitter. It can also be used to construct so many complex antennas like active antenna and long wire antenna, etc. And coming to the construction, speaking of the construction, as we know, the construction is equal to the half of the electrical wavelength of the antenna, and it has the center, and excitation of the half-wave dipole antenna is provided from the center, and we can say that the feeding of the antenna is present at the quarter wavelength point. This is the half-wave dipole antenna. As we can see, this is the wavelength lambda by 2, and this is the excitation part, and and working of the half-wave antenna is that when the input voltage or a sinusoidal voltage is given to the antenna, the current goes here, when positive goes here, it produces an antenna. As we can see, this is a dipole antenna, and the working of the dipole antenna is as follows. When the sinusoidal input is given, the current goes here, and it produces a sinusoidal waves which produces radiation. And according to the reception, and when it comes to the reception, this is the transmission part. How we can see the radiation effects. It produces an EMF around itself, and this is the when it comes to reception, it works in the similar way. We can see this is an EM wave. The green color signal is an EM wave, and the red and blue color signals are the reception signals. And this is the radiation pattern of an antenna. And the radiation pattern of the dipole antenna. The radiation pattern is similar to, as we can see, this is the reception part. We can see the voltage, the negative half cycle and the positive half cycles are same. So we can see this is the pattern where it produces omnidirection, where it has 0 to 180 degrees. It works in a 0 to 180 degrees. And advantages of this antenna is that the antenna is not bulky, it is cost efficient, and it is mostly used for, and it is also highly properly matches with the input impedance of the transmission lines. And this is the back. Now let me explain more in depth of the half-wave dipole antenna. We know that the half-wave dipole antenna is a metallic rod or a thin wire having a physical length of a half-wave wavelength of a free space. Excitation of this antenna is provided to the center where the voltage is minimum while the current is maximum. Thus the two quantities vary in a sinusoidal manner along the length of this radiation pattern. Also, so as the voltage varies sinusoidally, for the positive half of the voltage the amplitude is maximum, then the charge carries inside the conductor and gets attracted towards the positive applied voltage as against when the negative half cycle of a sinusoidal is provided, then charges present in a conductor experience repulsion, as we can see here. And so every time the charge is polarity of the applied signal, there is a change in the direction of the low flow of electrons inside the conducting wire. We can see the flow of electrons in this conducting wire. Since hence the back and forth movements of the electrons and end of the causes its charges to either go positively or negatively. This is cumulative action of the electrons lead to the generate current and field is radiation for the half wave dipole antenna. We can see from this example, it has been observed. We can observe that when the electrons move back and forth, the voltages also change according. Here we can see it is a half wave dipole antenna, and it is providing a feed point. In the similar way, the reception also works. When the voltages hit the metal conducting wire, the electrons conduct from the positive to negative, thus producing an sinusoidal wave. We can use this antenna for many applications. This is the radiation pattern we have seen again. And disadvantage of this antenna is that it cannot be operated at very very high frequencies. And it is omnidirectional ranger. To reduce the omnidirectional nature, we use something called as aguda antenna and long wire antenna. These and the applications of the antenna is that we can use it in the radio or television receivers, and this half wave dipole antenna can be built by using any type of wire, which is very advantages of this half wave dipole antenna. And thank you.